Okay, now we are looking at our last day for Unit 1, Kinematics number 6, Projectile Motion Continued. So our first question today is here. A batter hits a baseball so that it leaves the bat with an initial speed of 37 meters per second at an initial angle of 53.1 degrees. Draw a diagram representing the question. We're going to assume the ball leaves from ground level. So we know that if we actually were hitting a baseball, to think of how high a person is, we're probably hitting the ball about 1 meter off the ground. And then we have a series of other questions, B, C, D, E, which we'll get to. Okay, so let's draw our diagram first. So here's a line. First thing to recognize is that any projectile follows a parabolic path. Which you learned all about parabolas in grade 11 math. So the ball is going to be launched into the air. It's going to reach some vertex, and it's going to come back down to the earth. So when we hit the ball, and the velocity is represented by the tangent line drawn at any point. I try to draw the tangent right there. You can also see that if we drew other tangents, we can see what's happening to the velocity. At the vertex, the tangent of this parabola is perfectly horizontal. And so on. Okay, so I just drew some tangent lines. So what we know about this one, if we look at just this first velocity vector, we know it has an x component and a y component. So I'm just going to draw that in. So it has a x component, so v initial y, so y component, and also has a v initial in the x direction. I'm actually going to draw it off to the side over here too. So here is that first vector we drew, 37 meters per second. So if I draw that triangle, and we can use what we learned about components in the previous topic, that the y component right here is going to be 37.0 sine 53.1 degrees. Because this is our angle 53.1. The x component is going to be 37.0 cos 53.1 degrees. So we end up with, in the x direction, we have an initial speed of 22.2 meters per second. And in the y direction, we have an initial speed of 29.6 meters per second. So to make sure that you are in degrees, not radians. So because of symmetry of a parabola, what we also recognize is at this point, for example, this is also going to have an x and y component. Again, our v final x is actually equal to our v initial x, because remember, there's no acceleration in the x direction. And in our y direction, because of symmetry, we actually know that v final here, v final y, is actually equal to just the negative of v initial y. So the speeds are the same at this point, just the direction has changed. Same if this point lines up, with this other one, we know that the speed of those two vectors are the same. However, it's just the direction has changed. So before it was angling upwards, now it's angling down. One other thing to make sure we recognize is that if we look at the x component here and the x component here, remember the velocity in the x direction hasn't changed. So this is still vx. This is still vx. However, we can clearly see that vy has gotten smaller. So v right here, it's a smaller arrow than it was initially. So overall, our speed is decreasing. At the vertex, it only has an x component. The y component is now 0. So therefore, at the vertex, the speed is actually the lowest. The magnitude of the velocity is the lowest compared to any other point along the parabolic path. So here's question B. How long is the ball in the air before it reaches the ground? So we can use the equation Vy is equal to V0y or VIY plus AT. Now if we figure our values, we know that, okay, initially our velocity is, so V0y, it's off to the side. That value we found, oh, that's 29.6 meters per second. I'm actually defining up as positive, okay? So up is positive. What's my final velocity? V final y. So because of symmetry, we actually know that this value is going to be negative 29.6 meters per second. And acceleration is just equal to gravity. But because we defined down as negative, because up is positive, we actually have to make sure we don't forget that sign, negative 9.81 meters per second squared. Okay? So we're going to find out how long it takes for the velocity to go from positive 26.9 all the way to negative 26.9. We can actually just plug in our values. Our final velocity is going to be negative 29.6 meters per second. Our initial velocity was 29.6 meters per second. That was positive. Plus our acceleration is negative 9.8 meters per second squared times time. So now we solve for this. We have negative 29.6 minus 29.6 because we're at a group-like terms. We divide by negative 9.8. We get a time of 6.04 seconds. The other way we could have solved this would be to solve for when does the time for the velocity to reach its vertex. The time for it to reach its vertex would be from the time for the speed to change from positive 29.6 meters per second all the way to 0 meters per second. If we know the time for it to go upwards, we know the time to go down is just the same amount, but it's traveling in the opposite direction.